So in this video we will study about the reaction quiotient. So what is the meaning of reaction quiotient? What if the reaction is not at equilibrium? How do we know? Use the reaction quiotient, and Q is determined exactly as K would, but using concentration or pressure that are not necessarily at equilibrium. Right, for an example, if this reaction is written A and B are reactant and C and D are product, and small a, small b, small c, small d are the coefficient. So K is also, when we write equilibrium constant, we also write product divided by reactant, same way we write the reaction quiotient also. The only difference is this one, that when we do not know if the reaction is reached to the equilibrium, then we calculate Q. So determine Q with the given concentration or pressure and compare K and Q. So here is one simple sentence I will say. You should remember or note down that when you know you are in equilibrium, calculate K. Right. So this is very good correlation between that. When you know, then calculate K, and when you have question on equilibrium, then calculate Q. So when you do not know and you are questioning whether my reaction reached to the equilibrium or not, basically we calculate Q. So when you know you are in equilibrium, calculate Q. When you do not know, or when you have a question on equilibrium, calculate Q. Right. So this is very good information to know whether we reach to the equilibrium or not. Then what is how we are going to compare these K and Q? So what is the difference between? So Q allows us to determine which way a reaction would go, forward or reverse direction. If K and Q both are equal, then system is at equilibrium. Right. So three conditions are there. If Q is smaller than Q, if Q, the value of Q is smaller than K, it means not enough product. Reaction proceed from left to right, forward direction. Right. Not enough product, and reaction will move to the left to right. And if K is small than Q, or Q is greater than K, then too much product is there. So here product is larger, and here reactant is larger, and product is small, reactant is small. Like, so this way we can understand. And reaction proceed from right to left in the reverse direction. So this is the way we can compare it. Another way we can use this chart to compare whether, if this is the situation where K and Q both are equal, this is at equilibrium. This line represents the equilibrium line, dotted line from top to bottom. And if K value and Q values are equal, it means reaction is at equilibrium. And if Q value is smaller, for an example, this one, Q value is smaller, right? So Q value is smaller, reaction form product. So basically in this situation reactant is large. If reactant is too much, then still Q will be less and product will be less. So it will form more product. So reaction will move towards product side. And if Q is larger, it means there is a lot of product, and a small reactant is there. So reaction will move towards the product side to make it balance. So these are the two important slides to understand what is the difference between K and Q and how we can compare. Now we will use one example to understand what is the how we can calculate and how we can compare these two conditions. So for an example, if this reaction is here, which is at 100 degrees Celsius, equilibrium constant for this reaction is given, which is K is given for this reaction is this much. And by seeing this reaction, I mean if you see this reaction, K have 2.19 times 10 to the minus 10. I mean K value is very small. K value is very small, right? So look like this reaction is going very slow in the forward direction, and mostly reactants are there. Calcium chloride hardly dissociating into cobalt chloride is hardly dissociating into cobalt and chloride. So is the following mixture of the reactant and product at equilibrium? So here is the question. If reaction is in equilibrium or not, it means we have to calculate Q. What direction must reaction proceed to achieve, right? And these are the concentration are given. So what we have to do, we can calculate Q for this reaction. So Q we will calculate, Q will be equal to product CO and then Cl2 divided by COCl2, and the concentration of product is 3.3 times 10 is power minus 6 multiplied by 6.62 times 10 is power minus 6 divided by 2.0 times 10 is power minus 3, and they are in molarity. Once we will solve this question, I have already done the math, but you can confirm if this is correct. My calculation came, which is around 1 point, I round up actually already, 1.1 times 10 is power minus 8. Basically I got 10.92 times 10 is power minus 9, which I corrected it, this one here. Okay, so this is my Q value and K value is given here. So this is Q, and K value in the question they have given 2.19 times 10 is power minus 10. So basically if you compare these two values, Q value and K value, so K is smaller than the Q, so basically Q is larger than K for this reaction. And if Q is larger than this reaction, it means what? It means Q is larger than K. It means there are a lot of product, it should go back to reactant side, right? So reaction will move toward in reverse direction. So this is the way we can understand K and Q and how we can compare. And in the next video we will study about the ICE chart.